In this problem, we need to verify that this particular equation holds true whenever we have x given by cosine of theta plus iota times sine theta and the relation square root of 1 minus c squared equals nc minus 1. So let's begin. So what we'll do, we'll start from the right hand side of a given expression. So here we have c over 2n. So here we have 1 plus nx multiplied to 1 plus nx. So if we distribute them, or that will multiply both of them, then we should get 1 plus nx plus n over x plus n times x multiplied to n over x. So here x and x gets factored out and this gives us n squared. That will leave us with c over 2n, 1 plus n squared, plus here we can take n as the common factor. So we'll have n multiplied to x plus 1 over x. So we'll get c over 2n multiplied to 1 plus n squared plus c over 2n multiplied to n times x plus 1 over x. Or simply put, we have c over 2n multiplied to 1 plus n squared plus here the n and n will get factored out. So we have c over 2 multiplied to x plus 1 over x. So this is what we have obtained into right hand side. We'll come back to this in a moment. First, what we'll do, let's go back to our equation. So here we have square root of 1 minus c squared. So this is given that this is equals to nc minus 1. So what we'll do, we'll square both sides of the given equation, and this should give us 1 minus c squared equals to n squared c squared minus 2nc plus 1. The 1 and 1 will get cancelled out. So this will become n squared c squared plus c squared equals to 2 times nc. So we can take, we can divide both sides with c. So we'll have n squared c plus c equals to 2n. Now what we'll do, we'll take c as the common factor from the two terms and divide by 2n, which should give us c over 2n multiplied to n squared plus 1 equals to 1. So here we have obtained that this value is actually equals to 1. So that means we have 1 added to c over 2 multiplied to x plus 1 over x. Now if we look at the left hand side of a given expression, so we have obtained this particular 1. So we have c over 2. So now we have to work with the second term. So here we'll start with this particular relation. Here we are given that x equals cosine of theta plus iota times sine theta. So let's begin with that. So we have x equals to cosine of theta plus iota times sine theta. And if we take 1 over x, the 1 over x is actually x raised to the power of negative 1. And in place of x, we can replace with x cosine of theta plus iota times sine theta whole raised to the power of negative 1. Using de Moivre's theorem, we have cosine of negative theta plus iota times sine of negative theta. Now we know that cosine is an even function, so cosine of negative theta will be simply positive cosine theta, but sine is an odd function, so we will have negative iota times sine theta. So this is the value of 1 over x. Now when we add x and 1 over x, so this should give us 2 times cosine of theta. We will replace this value in place of x plus 1 over x. So that means this expression will now become 1 plus c over 2 multiplied to 2 times cosine theta. So the 2 and 2 gets factored out, and that finally gives us 1 plus c multiplied to cosine of theta, which is the expression on the left hand side. So hence we have successfully showed that this particular equation is true whenever we have these two conditions.